and explore solids. Here is the definition of polyhedron. Polyhedron is a solid that is bounded by polygons called faces. I said faces. What are faces? I explained it, yeah? And that enclose a single region of space. An edge of polyhedron is a line segment formed by the intersection of two faces. I said intersection of planes, yeah? Plane, actually, face. For example, we can say this is one plane or face. Face, face, face. Intersection of this face and this face, it provides this edge. Yeah? And a vertex, what does it mean? Vertex, you know. So many times we repeated vertex, yeah? A vertex of polyhedron is a point where three or more edges meet. The plural polyhedron is polyhedra or polyhedrons. Both are correct. We can say polyhedron or polyhedra. Both are possible. Both are correct. And here are examples of polyhedron, and they are not polyhedra. Why? Because they don't have face. They don't have face. They are circular figures. Yeah? Circular figures. Did you understand the meaning of this one? Circular figures. Or we can say base of this kind of solids are circles. They appeared by means of circles. That's why they are circular solids. Okay? These are polyhedrons because there are faces. That's why. This pyramid, prism, cylinder, cone, sphere. Who has any question now? Who has a question? No? Classifying solids. Classifying or a classification of solids is based on what kind of figure is in the base of this kind of solids. For example, what kind of figure in the base of this one? Pentagon. That's why it's called pentagonal prism. Triangular pyramid. What is the base of this one? Triangle. That's why it's called triangular pyramid. And you can see here prism. Just the first base and the second base, they are the same. They are the same. Okay? Here is written, the two bases of prism are congruent polygons in parallel planes. Congruent means the same, what I said. Okay, here are some questions. Tell whether the solid is a polyhedron if its name, the polyhedron, define the number of faces and vertices and edges. What's the name of this one?
Prism. Rectangle.
What kind of prism? Rectangular prism. Rectangular prism. This one? What are you talking about? Triangular. Is the basis triangle? What? Yes, it's pyramid. But what's base of this one? Hexagon. Hexagonal pyramid. Hexagonal pyramid. What is this one? Cone. Cone. Just it's upside down, not just the vertex. Vertex is not above, below. Okay, upside down shape or form of cone. So what is the vertex of this one? What are vertices here? This one, this one, this one, this one. These are vertices of prism. And vertex, actually this is one main vertex of pyramid. First one. And This is also vertex of cone. Okay, vertex actually highest or lowest. Here highest. Okay, and in the beginning we said in geometry vertex actually is a point which edges meet. Yeah. So here is the solution. A1. The solid is formed by polygons, so it's a polyhedron. Yes, we said polyhedron. The two bases are congruent rectangles. Congruent rectangles. So it's a rectangular prism. Yeah. It has 6 faces. 1, 2, 3, 4, 5, 6. And 8 vertices. 1, 2, 3, 4. 1, 2, 3, 4. And 12 edges. That's it. So B1. The solid is formed by polygons, so it's a polyhedron. The base is a hexagon, so it's hexagonal pyramid, yeah? It has 7 faces of one base, 3 visible triangular faces, yeah? And 3 non-visible triangular faces. Why visible, why non-visible? Because 3 of this in front of you, it's visible, but 3 of this behind the figure, it's not visible for us. Okay? And polyhedron has 7 faces and 7 vertices because it's hexagon, 6 vertex and 1 vertex, 7. And 12 edges. That's it. So C1. The cone has a curved surface, so it's not a polyhedron. Yeah? Now, here is the rule. Here is the rule. Euler's theorem. Euler's theorem. Actually, this person in Russian, Euler. Euler's theorem. This person did so many contributions into mathematics, and one of this today, Euler's theorem, and it's about finding or calculating number of edges, faces, and relationship between faces and edges. Okay, this is theorem. The number of faces, vertices, and edges of a polyhedron are related by this formula. For example, we can say, in the question might be given, for example, faces, number of faces and number of edges, and question might ask you to find vertices, number of vertices. In order not to spend so much time on solving this question, you can use this formula. Okay, if faces 8, adds 12, in this case 8, 12, it's going to be 14 minus 8, V6, vertices are 6.
Всем привет! Меня зовут Васивара. И да, сегодня очень особенный день, потому что вышли ответы экзаменов Вестминстерского лицея. И да, я поступила. Я в это не верила до того, как я не пришла в учебный центр Real Science. Я пришла сюда 7 июня 2018 года, за месяц до экзаменов. И я не верила, что я поступлю в этот лицей. Хочу поблагодарить за достижение моей цели этот учебный центр, также моих родителей и замечательного преподавателя Окалекя. Спасибо за его терпение, за его труд, потому что это нелегко. Спасибо моим родителям, которые все время поддерживали меня. Я думала, это нереально поступить в Вестминстерский лицей. Всем советую посетить этот учебный центр, и вы останетесь довольны. Real Science супер!
Such kind of solution. So for now, who has a question? No? Here's the question for this theorem. The frame has one face and its foundation, 4 that make up its walls, and 2 that make up its roof, for a total of 7 faces. To find the number of vertices, note that there are 5 vertices around each pentagonal wall and there are no other vertices, so the frame of the house has 10 vertices. Use Euler's theorem to find the number of edges. Okay, 7 and 10. If we put instead of this one 7 and 10, E is going to be 15. It's so simple, quite simple. Yeah? If you know formula, quite simple. Now, the second information, regular polyhedra. Regular polygon, irregular polygon, such kind of things are not unfamiliar to you. Yeah? They're familiar to you. Regular means all edges or all sides are equal, but now we are talking in 3D figures. In this case, all edges are equal. Yeah? Irregular, all edges are not equal. Regular convex, non-regular concave. You can see here all angles are directed outside, and here there are angles which are inside of the figure. Yeah? And Platonic solids, actually, because Plato said the name of these figures. These are solids which are learned in 3D geometry. Okay? These are names of all of this. Regular tetrahedron, 4 faces. Tetrahedron means 4 faces. Tetra, it's from Greek language. Tetra means 4. Okay? And cube, all sides are equal. Here, students, edges are equal, absolutely equal, all edges. Okay? And they have specific names. For example, actually it's pyramid. Yeah? It's pyramid. But if all sides are equal, all edges are equal, name is going to be tetrahedron. If question says tetrahedron or some kind of formula, some kind of numbers are given related to tetrahedron, in this case tetrahedron is tetrahedron, just triangular pyramid. Just only sides or edges are equal. Triangular pyramid, but regular. All edges are equal. The same value, 777, for example. And cube. You know cube. Cube has also the same and equal sides, faces, edges, dimensions. Yeah? And regular octahedron. For example, you can see here pyramid, but below also pyramid. Yeah? Such kind of figure is called octahedron. Why octahedron? Because 4 triangles above, 4 triangle faces below. Overall, 8. Octa means 8. Hedron face, 8 faces. There are 8 faces. And regular dodecahedron, regular icosahedron. You'll have a lesson on this kind of figures, solids, deeply in the continuation of your learning mathematics. But for now, knowing the names all of it, especially dodecahedron, icosahedron, is enough. Knowing it enough. But for 11th grade students, 11th grade pupils, it's pretty obligatory to learn this one. Because such kind of figures are taught in higher classes. In lower classes, just only introduction to this one. Not deeply, not questions, okay? But these four tetrahedron, cube, octahedron are used more, are used widely in lower class too. Okay, this first 3 one. Again, Euler's theorem with Platonic solids. Find the number of faces, vertices, edges, and a regular octahedron. Check your answer using Euler's theorem. Okay. Faces. We said 8 faces because octahedron. Octa means 8. Hedron face, 8 faces. And vertices. How many vertices? 1 above, 1 below. And 4? 6 overall. What about edges? 8, 8, and 4, 12. Yeah? 4 above, 4 below, and in the middle of this one also 4. Overall 12. Yeah? And 12 we got. 8 faces we got. 6 vertices we got. Correct. Correct. That's it. This is a true statement. So the solution checks. That's it. Cross section. Now you can see here cross section. This kind of section is called cross section. For example, you have, imagine you have pyramid, and you are just cutting this pyramid with plane, some kind of plane. For example, it's rectangular plane. We are cutting by means of this one, and we are having cross section by doing this one. First one, describe the shape formed by the intersection of the plane and a cube. Again, rectangular figure. It was cube. Yeah, it was cube. If we do cross section, shape, inside shape, just the section shape. It's again square. Yeah, because all faces of cube are squares. If parallel, perpendicular, we cut cube, we'll have again square, the same face. But what about here?
Rectangle.
It's rectangular. Yeah, this one rectangle. Yeah, this one rectangle because it's the diagonal of the face. Diagonal is a square root of 2, and this is a square root of 2, a square root of 2, a. It's a rectangle. What about this one?
Trapezoid.
Trapezoid. How did you find it? How did you find it?
Two sides are equal and another two sides are parallel.
Two opposite sides are parallel.
And another two sides are equal.
Which two sides are parallel here? This one, yeah? This one is actually trapezoid, yeah? These are parallel, and these are side. That's it. These are sides. And these are parallel, but they are not parallel. In this case, this is trapezoid. So, up to now, was it understandable? Identifying polyhedra. Now again exercises, skill practice. Name the 5 Platonic solids and give the number of faces for each. What actually are the Platonic solids? Remind me please. Now we're talking about this. What are Platonic solids? Cube. It's the second one. What about the first one? Tetrahedron, first one. Tetrahedron, cube. Icosahedron. Regular octahedron, regular icosahedron. Regular dodecahedron. Yeah? We said all of this. And state Euler's theorem in words. Why do we need actually the theorem of Euler?
and
What actually does this theorem show?
The number of
Relationship, yeah? Relationship among its vertices and faces of solid. Yeah? Who can tell me equation of Euler?
A equals to H plus B.
F plus V equals E plus 2. Correct. So third one, determine whether the solid is polyhedron. If it's named the polyhedron, explain your reasoning. This one. It's polyhedron. Pentagonal polyhedron. Okay, the second one. Hexagonal polyhedron or hexagonal prism. It's prism, it's pyramid, they are polyhedron. What about this one? No, it's not polyhedron because a kind of spheric, circular part of this one exists. Huh? Yeah, semi-cylinder we can say. And it's not polyhedron because of this one. So, error analysis. Describe and correct the error in identifying the solid. The solid is a rectangular prism. What's this?
Triangular
rectangular pyramid.
Triangular, yeah, triangular. Just it lies, yeah? The difference is it lies. That's the reason. Actually, it must be like this. Prism, it was prism. And that's the mistake. Sketch the polyhedron. No, we don't need to sketch.
Mening ismim Jamshid. Men bu o'quv Real Science o'quv markaziga 1 yildan beri kelaman va bu 1 yil ichida men juda ham ko'p narsalarni egalladim va o'rgandim va buni imtihonda qo'lladim va o'z kuchim bilan Vestminster akademik litseyiga qabul qilindim va bunda Real Science o'quv markazidagi o'qituvchilarning hissasi juda ham katta. Bunda Oqil aka, Mansur aka va boshqa yana ko'pgina o'qituvchilar menga juda ham ko'p yordam berishdi. Ota-onam meni qo'llab-quvvatlab turishdi va men zo'r natijaga ega bo'ldim. Hammalarni tavsiya qilaman Real Science qo'shimchasiga kelishga.
Let's solve some questions applying Euler's theorem. Use Euler's theorem to find the value of n. We know vertices, number of vertices, adds. Again, repeat the formula. F plus V equals E plus 2. Okay, n plus 12 equals 18 plus 2. 20 minus 12, 8. And 8 plus 2, 10, minus 5, 5. And 10 plus 16, 26, minus 2, 24. This one. 20. 30 plus 2, it's 32, minus 12. It's 20. Yeah. So applying Euler's theorem, find the number of faces, vertices, and adds of the polyhedron. Check your answers using the Euler's theorem. Okay. But it's visible. Anyway, question is asking, okay, it's triangular prism, triangular pyramid, yeah, triangular pyramid, and we have 6 vertices, and we have 4 faces, we have 4 vertices, yeah?
12 each. Or
6 sets. 6 sets.
4
6 plus 2 is 8. Sum of faces and vertices. We said vertex 1, 2, 3, 4. We said 4 faces. 4 plus 4, 8. Equal. They're equal. In this case, it's correct. What we found, it's correct. And you can find the others at home. It will be sent to your Telegram group. You'll be provided with this file at the end of the lesson, and you can solve the other questions at home. Okay, cross-section. Let's see cross-section. Question number 25, cross-section. Draw and describe the cross-section formed by the intersection of the plane and the solid. Okay, what kind of shape this cross-section? Circle. This one? If this is rectangle or solid, in this case rectangle. If this is cube, in this case square. We don't know it. We don't have exact information about this one. What about this one? Triangle. Yeah, triangle. Actually, now we'll have these circular solids. I will explain, but now I'm going to say anyway, additional information. Cone, how is cone formed? For example, let's say you have right angle triangle. Yeah, right angle triangle you have, and you are just circling this one, rounding this one. If you're circling this one, you'll have cone. One leg of this one will be height, one leg will be radius. Did you understand? Just circling this one. Okay. Oh, multiple choice question. Okay. Which two solids have the same number of solids? This one. Which two solids have the same number of faces? A. Triangle prism and rectangular prism. Okay, triangular prism, it means triangles are bases and faces are rectangles. Okay, and the same number of faces. How many faces we have? 1, 2, 3, and 1, 2, 5 overall. And rectangular prism, rectangles are bases, and 1, 2, 3, 4, 5, 6. No, they're not the same. Triangular pyramid and rectangular prism. Triangular pyramid, 1, 2, 3, and base 4. Yeah. Rectangular prism, we said 6. And triangular prism and square pyramid. Triangular prism, we said 5, and square pyramid 5, because square base is square, and we have 4 faces. 5. In this case, answer is C. Let's check D1 too, because we don't know. Perhaps it might be correct, more correct than this one. We don't know. We have to check it. A triangular pyramid, a square pyramid. Triangular pyramid, we said 4, and square pyramid 5. No, it's not correct. Sevara, do you have a question? No? Question number 32. The solid shown has 32 faces and 90 edges. How many vertices does the solid have? Explain your reasoning. F plus V equals E plus 2. E is 90. 90 plus 2, 92. Minus 32, 60. Yeah. 60 vertices. The other questions will be a home assignment. Okay? These are. I will send these questions and you will solve at home. Okay? Are you listening to me? Are you following? Okay. Surface area of prisms and cylinders. Can you remind me what was surface area? I said in the beginning of lesson. What's the definition?
One side of
Surface area. Surface. What you said surface, but I'm surface areas. Yeah, surface area, sum of all the surfaces or faces. Prism. A prism is a polyhedron. We define it. You can see here the surface area of a polyhedron is the sum of areas of its faces. The lateral area, or just surface, of a polyhedron is the sum of areas of its lateral faces. Oh, sorry. Sum of only, side faces. Yeah, bases are not included. Lateral area. Lateral area without bases, without the sum of area of bases. And surface area, sum of all faces. Okay? That's it. Imagine that you cut some edges of polyhedron and fold it. Unfolding, especially this word. Unfold means expanding. For example, we have a kind of, as I said, Rubik's Cubic, and if you open this one, we're going to have how many sides? Six faces, yeah? 6 faces, 6 squares we will have. And that actually, the two-dimensional representation of faces. As I said, 2D, I said when I explained. Two-dimensional representation of the faces is called a net. Sadullah, do you have question? No. Are you fine? Okay. Firdaus? Okay. I hope you are not sleeping. So, you can see here example of net of prism. Find the surface area of rectangular prism with height 2 centimeters, length 5 centimeters, and width 6 centimeters. First of all, for prism, I said in the beginning, distance is the same between two bases. Distance is the same. Distance, it's height. 2, 2, 2. In this case, it's 5, 5, 2. Such one rectangle, and another 2 the same rectangles, and bases also another 2 rectangles. Yeah, it means 3 couple of the same area of rectangles. 3 couple. 5 times 2, 10, 10, 12, 20. Yeah, 6, 2, 12, 12, 24, and 5, 6, 30, 30, 60. 20 plus 24 plus 60, 104. It is surface area. What about lateral area? Lateral area without considering these two bases. 30, 30. We don't add this one, 44. What about surface?
100.
It might be different. Surface. Surface, only one, this one. Face. Yeah? 5 times to 10, perhaps 12, 30. One of these 3 faces might be surface of one face. Okay? And this is net. You can unfold. Unfold is opening, expanding it, and calculating each of this. The same, and this also the same. These are also the same. 3 couple of rectangles. Did you understand? Oblique and right. Right means angles 90 degrees. Oblique, it's a kind of slope. There is slope, okay? And in the beginning I said oblique, different sides, different measures, yeah? Different measure, I meant about height. Height is different as this one, okay? Height is different as this one. It's not the same. For example, here height is just side itself, but here height will be different. Okay? To find height, you're going to put height and continue this side and solving by using the Pythagoras theorem. Surface area of right prism. What is P here? Perimeter, yeah? Perimeter. Where A is the upper thumb of the base, B is the area of base, P is perimeter of base, and H is the height. It's for any prism, but this side is for especially for this case. Sadala, this side of the formula is only for triangular. Why A here? A, it's upper thumb, okay? Upper thumb, and just this formula you can use. It's common formula for all. 2 bases plus perimeter of base multiplied by height. Okay? Area of 2 bases and plus perimeter multiplied by height of height. Perimeter, actually base, perimeter of base. Okay?
What is upper thumb?
A?
Yes.
A is upper thumb. Upper thumb is height. But sometimes it might be different. For example, there is no pyramid. If it was pyramid, it would be more understandable. For example, imagine we have pyramid and the base is square. We have 4 triangles, triangular faces, and height of this triangle will be 2 only like this. Height of this triangle, not pyramid. Pyramid's height will be like this, vertical. But height of this face is going to be inside of triangle. It's upper thumb. It's also height, but heights of lateral sides, lateral faces. But for prism, it's the same. What is the height of this face? The same as this side. Okay.
Всем привет! Я благодаря обучению в Real Science поступил в Вестминстерский лицей. Все материалы, которые мне давал Real Science, я старался усвоить по максимуму, и они мне очень помогли, особенно на экзамене. Хотелось бы особенно поблагодарить всех учителей и сотрудников Real Science, которые мне помогали и поддерживали. Экзамены были трудные, но именно благодаря всему тому, что мне дали в Real Science, большая часть вопросов были как раз-таки по тому материалу, что мы проходили, что позволило мне успешно поступить туда, без всяких проблем. Родители меня поддержали в том, что я хотел обучаться тут и решил именно поступить в Вестминстерский лицей. Занимался более 3,5 часов в день, использовал все свои возможности, поглощал весь материал, который только можно было. Тем не менее, я поступил в Вестминстерский лицей и уже в этом году собираюсь начать в нем свое обучение. И надеюсь, я также поступлю в Вестминстерский университет. Если вы хотите поступить в Вестминстерский лицей и построить дорогу для своего будущего, вам стоит посетить Real Science. Непосредственно хотелось бы поблагодарить всех, кто мне помог. И также замечательные тут также были ученики и учителя. Большое спасибо Real Science. Real Science поможет построить дорогу в ваше будущее.
Cylinder. Cylinder, actually, it's formed by circling a rectangle. For example, if we have A4 paper, if you just fold this, it's going to be cylinder. Fold, just closing it. Circling, just meeting 2 sides of paper, and we'll have cylinder. It is formed by using rectangle or square. We don't know. Rectangular shapes. It might be square or rectangle. You can see here. Yes, just combining this side and this side is going to provide us with cylinder. An area of this one is circle's area, pi r square. And length of this circle, circumference, is 2 pi r. And height, there is height. It's right cylinder, it's not oblique. Right cylinder means vertical, it's vertical, perpendicular, okay? And if it's a kind of oblique, it's going to be like this, oblique. A little bit sloper, yeah? It's not slope here, it's vertical. That's why it's right cylinder. And these two circles are bases of cylinder. This is radius of base, and height, distance between two bases. And lateral area, there is lateral area. As we said, this is actually rectangle. What is the area of rectangle? AB. Yeah? B is height. What about this A? A, it's length of circle. Length of circle 2 pi r. 2 pi r times H. Base area, base area. If we add all of this, we'll have surface area. Yeah? But lateral area 2 pi r h. 2 pi r h. Okay? Multiplication of this circle length of circle circumference, and multiplying this to height. Circumference and height, multiplying this 2 dimensions. Tamila, how are you doing? Do you have question? No? Okay. Circumference multiplied h plus 2 bases. 2 bases actually are circles. Area of circle is pi r square. 2 pi r square plus 2 pi r h. Circumference 2 pi r, it's h. That's it. Theorem, or just the surface area of right cylinder. Bahara, do you have question? No? Okay. For now, is everything understandable, or you have questions? No? Let's see examples. Example number 3. Find the surface area of a cylinder. Compact discs. You are wrapping a stack of 20 compact discs. What does it mean, stack? Stack, batch, these are just group of discs, that's it. Stack or batch, it means group of discs, okay? Stack, batch. Batch means B-A-T-C-H, batch, stack. You are wrapping stack of 20 compact discs using a shrink wrap. Each disc is cylindrical with height 1.2 millimeters and radius 60 millimeters. What is the minimum amount of shrink wrap needed to cover the stack of 20 discs? What does it mean, wrap? Covering, yeah? Covering by using what? By using shrink wrap. They said shrink wrap, yeah? To find it, we have to calculate area of this cylindrical stack of compact discs. And we know the formula. Surface area is found by using this formula. 2 pi r square plus 2 pi r h. Question said height is 1.2. Radius is 60 millimeters. Yeah? Okay. Okay. Instead of h, we're going to put... first of all, height is each disc. Each disc. We have 20 discs. We're going to multiply this 20 to find overall height. 20 times 1.2, it's 24 overall height. Now we have overall height. And radius is 60 millimeters. Now we can use formula. It's instead of this one 60, instead of this one 24. And 2 pi 60 square plus 2 pi 60, 24. If we multiply and calculate, 31,667. But it's in a millimeter square. Millimeter means it's so little. Yeah? And that's why number can be a big number, but amount, actually value of this number is quite small because it's in millimeter square. Okay. Another example, finding the height of cylinder. To find this, first of all, we can use what is provided here. Yeah? Let's clarify what's provided. Find the height of right cylinder shown, which has a surface area of 157.08 square meters. Solution. Okay, if we have surface area, this one, and the solution. By the way, we have a radius also, yeah? We have radius also, 22.5. Radius also is given. And we know a formula, instead of radius 2.5, and instead of surface area 157.08, and just calculation finding h. After calculating, squaring this one, multiplying this one, 5, square of this one 6.25, 6.25 multiplied 2 at 12.5, and 12.5p must be transferred to the other side because it's constant, it's exact number, and a noun left on the right side. To find a noun, we have to divide it, and instead of pi, they use it approximately a value of pi, 3.14. That's why they wrote approximately. And h is approximately 7.5. Just calculation, if you know this formula, you can find. If you know the formula, you can find. But main difference or main things which you have to pay attention are just difference between the terms, terminologies of this one, lateral area, surface. You have to differentiate. You have to be able to differentiate what actually this kind of terms provide. Okay, you with information, what type of information they provide, you have to understand. Because it's easy, quite easy to confuse you. Yeah, surface and surface area. Surface area is the sum of all the faces, yeah, area of faces, and surface just one faces area, lateral area, sum of all surfaces, or just the without bases, only some of the other faces. Okay, area of the other faces. So now we'll continue. Guided practice for examples 3 and 4. Find the surface area of the right cylinder with height 18 centimeters and radius 20 centimeters. Round your answer to 2 decimal places. Formula S equals 2 pi r squared plus 2 pi r h. Just replacing and calculating. Okay. These are exercises which you will solve at home. Okay. Let's see cylinder. This question. We have radius. We have surface area. Question is asking to find x, height. Again, the same formula, s equals 2 pi r square plus 2 pi r h, and we have radius, we have s, calculating h. As the example which solved is the same as this question, okay? So Tamila, do you have question? Boysunwa, do you have? No? Shahzada? Let's see question number 17, multiple choice. Length of each side of cube is multiplied by 3. What is the change in surface area of the cube? First of all, let's find surface area of cube. How many faces are in cube? 6 faces. What is the area of square? A square. Why square I'm asking? Because faces are square for cube. A square times 6. 6a square. Okay, if instead of a we write 3a, yeah, because question says like this, 3a in parentheses, and there is power 2, 9a square. 9 times, yeah,
54.
no, we don't need to calculate, because 6 coefficient, it's always the same. It's coefficient, the formula. What happened here, or what is new, is this 9. After adding 3, because of there is power, we got 9 times more than the previous one. See, surface area is 9 times the original surface area. So who has question? Nobody has a question. Okay. Okay, hearing none, we're going to continue. 18. Surface area of cylinder. The radius and height of right cylinder are each divided by square root of 5. What's the change in surface area of cylinder? Okay, first of all, what is the formula? S equals 2 pi r square plus 2 pi r h. Yeah? Yes, Sadullah, you have question? Okay. It's going to be divided. Yeah? Divided means in fraction, in denominator we're going to write. Radius over square root of 5. In the first part there is square. What is the square of this one? Radius square over 5. 2 pi radius square over 5 plus 2 pi r over square root of 5 h over square root of 5. It's square root of 5, square root of 5, it's going to be 5. In both parts of the formula we have 5. It means in denominator, common denominator we have in fraction. 5. It's being divided by 5. 5 times? 5 times? Minimizing, smalling, decreasing. Islam? How are you? How's it going? I think you understood the lesson and you prepared questions and you're ready to ask questions, yes? You can ask if you have question. Okay. So, these are questions which you will solve at home.
Assalomu alaykum azizlar. Biz juda ham xursandmiz. Meni qizim Kariyeva Malika bugun mana to'g'rirog'i kechqurun aniq bo'ldiki, O'zbekistondagi nomer 1 litseylardan bittasi bu Vestminster universitetini akademik litseyga o'qishga kirib ketdi, o'zini bilimi bilan, o'zini aqli bilan. Albatta bu yerda realskaya o'qituvchilari sabab bo'lishgan bular. Juda ham xursandmiz. Butun oilamiz bilan kechadan beri bayram qo'shishdan to'xtamayapmiz. Shuning uchun Oqiljonga o'zimizni отдельно boshqatdan rahmatimizni aytamiz. Butun hamma kollektivga, hammalariga shuncha mehnat qilishgani uchun juda ham kattadan katta Mansurjonga, hammalariga katta rahmatimizni aytamiz. Bular juda ko'p mehnat qilishdi, hatto Biz bu o'quv markaziga 2,5 oy oldin kelgandik. 2,5 oy ichida bizga shunaqa rezultat ko'rsatib berishdiki, bularni tuzgan отдельный grafik, o'qish grafiki bilan shunaqa rejim bilan qilib berishdiki, mana 2,5 oyda juda ham kolossalniy katta xayolimizga kelmagan rezultat ko'rsatdi. Buning uchun avvalambor shu Real Science o'quv markazi juda ham qoyilmaqom markaz. Bu birinchi praktikamizdagi birinchi anaqa situatsiya emas. Mana birinchi o'g'lim Sherzod Kariyev hozir Janubiy Florida universitetida 2-kurs talabasi. U ham shu universitet kirishdan oldin, litseylarga kirishdan oldin именно shu oqiljonning qo'llarida, shu kollektiv qo'lida o'qib, juda ham katta rezultatlarni ko'rsatib, Interhouse litseyini tugatib, undan keyin Amerikaga o'qishga kirib ketdi. Qizimizni ham shunaqa rezultat ko'rsatadi degan umiddamiz. O'shaning uchun shu o'quv markaziga olib kelgan edik. Juda ham xursandmiz sizlardan. Rahmat bolalar. Eng hayolimizdagi eng orzu umidlarimizni eng cho'qqisiga chiqarib qo'ydinglar. Shuning uchun Real Science'da hammanglar o'qishinglarni tavsiya qilamiz. Juda zo'r, krutoy o'quv markazi. Albatta rezultat bo'ladi. Juda ham xursandmiz. Rahmat.
Assalomu alaykum. Bugun mana o'zimni his-tuyg'ularim bilan litseyga kirganligim baxti bilan sizlar bilan bo'lishmoqchiman. Litseyga kirish uchun juda ham katta harakat qildim. 2,5 oy vaqt qolganda men Real Science uchun centerga keldim. Menga juda ham katta yordam berishdi. To'g'risini aytaman, juda ham qiyin bo'ldi. Kechalari uxlamay dars qilib chiqqan paytlarim ham bo'ldi. Ertalabdan kechgacha dars bilan shug'ullandim va Real Science menga juda ham katta yordam berdi. Bu yerda biz juda ham ko'p soatlab dars qilgan paytlarimiz bo'ldi. 2,5 oy oldin shu yerga kelganimda, menda mock topshirganimda matematikadan 30% chiqqan, lekin ekzamenda menda 70% chiqdi. 70% olish uchun juda ham katta mehnat qildik. Biz ko'p Real Science'da ko'p mock testlari bo'ldi bizda va mock testlargacha biz juda ham katta mehnat qildik. Prezentatsiyalar ishladik, mensuration, vektorlarni ishladik, juda ham ko'p marta ishladik va Oqilaka bilan alohida o'zimiz hammamiz doskalarga chiqib ishladik. Oqilaka har doim bizga tushunmagan narsalarimizni tushuntirib beradilar va o'zlari ko'rsatib bizga o'rgatadilar va agar sizlar shu narsalarni qilmasanglar, agar tayyorlanmasanglar, dars qilmasanglar, sizlar rezultatlar ko'ra olmaysizlar, o'qishga kira olmaysizlar. Shuning uchun hozirdan dars qilishni, hozirdan harakat qilishni boshlanglar. Harakat qilganinglar o'zining samarasini beradi. Oxirida shuni baxtini topasizlar. Va yana bitta narsani aytmoqchiman. Biz prezentatsiyalar ishlayotganimizda, домашняя работаga prezentatsiya ishlayotganimizda juda ham ko'p zadanyalarni ishlagan edik. O'sha bizani toch ishlagan zadaniyamiz ekan. Biz bundan hayron qoldik, lekin o'zimizning harakatimiz zo'yaga ketmaganiga amin bo'ldik. Juda ham ko'p harakat qildik va zadanyalarni ishlayotganimizda o'zimiz ham o'ylamagandik shunaqa rezultatlar bo'lishini, lekin shunaqa rezultatlar, shunaqa yuqori ballarni qo'lga kiritdik. Shuning uchun men Oqil akaga, Mansur akaga, Mismalikaga juda ham kattakon rahmatimni aytaman. Juda ham minnatdorman ulardan. Ular bo'lmaganida bu rezultatlarni ko'rmagan bo'lardim. Juda ham baxtliman. Vestminster litseyining studentkasi bo'lganimdan bu juda ham katta baxt va hozir mendan baxtli inson bo'lmasa kerak deb o'ylayman. Va ota-onamga kattakon rahmat aytaman. Ota-onam har doim meni qo'llab-quvvatlashadi. Har doim meni oldimda bo'lib qo'llab-quvvatlashadi va akamga ham juda ham katta rahmat aytaman. Sherzod akam juda ham aqlli insonlar va har doim meni qo'llab-quvvatlab, menga yordam berib, vaqtlarini ayamay ishlasalar, o'qisalar, vaqtlarini menga ajratib, men bilan shug'ullanib, men bilan speakingda qilib, tayyorlab meni va socheniylar yozdirib, meni qo'llab-quvvatlab keldilar va men ularga juda ham katta rahmatimni aytaman. Kattakon rahmat hammaga va sizlarga ham bunday baxtga erishishinglarni tilab qolaman. Buning uchun juda ham katta harakat qilishinglar kerak. Real Science'ga kelinglar, juda ham zo'r учебный center va sizlarni orzularingizga yetishga yordam beradi. Kattakon rahmat.